So number one gives us a quadratic function. It is f of x equals 2x squared plus 4x minus 3. So this is number one. And it asks us to do lots of different things with it. The first thing that we're asked to do is we're asked to put it into standard or vertex form. And again, you will have that formula with you. You do not have to have that or the quadratic formula memorized. So that is f of x equals a x minus h squared plus k. And that is going to give us the vertex. So the first thing I'm going to do is I'm going to factor a 2 out of just the first 2 terms. Okay? So I factored a 2 out of just the first 2 terms. I'm going to leave that in the parentheses, and that negative 3 is going to be on the outside. Okay? Then I'm going to take half of 2, which is 1, and I'm going to square it. And I'm going to add that inside. Now, this is where students make mistakes. You have to remember that this 1 right here is being multiplied by this 2. So I'm really not adding a 1 to the function. I'm adding a 1 times 2 to the function. So since I'm keeping everything on one side of the function, and what I've added is positive 2, what do I need to write on the outside? Negative 2. I've got to do the opposite there. So I should have negative 2 on the outside. And then it works real nicely. You factor, you get x plus 1 squared minus 5. And that is the standard or vertex form right there. And from that, we are able to identify our vertex. Our vertex is negative 1, negative 5. And that's because this is x plus 1 right here, but my formula is x minus h. Okay? So x plus 1 is actually x minus negative 1. So my h value there is negative 1. And that's actually probably another area students get a little confused about. Okay? My axis of symmetry is just my x coordinate of my vertex. It is important that you realize that that is a line. So it is going to be x equals negative 1. The axis of symmetry, I'm going to write that down. Axis of symmetry is a line. And it's a line that goes through the vertex. Okay? Part D wants to know our y-intercept. To find our y-intercept, we go back to the original function and we plug 0 in for x. So we would have 2 times 0 squared plus 4 times 0 minus 3. What would that be? 0, negative 3. Excellent. Good. And E wants us to identify our zeros. Okay? So we are going to set the function equal to 0. So I have 0 equals 2x squared plus 4x minus 3. Okay? I'm hopeful that I can factor. Okay? So I am going to do 2 times negative 3. So I have a product of negative 6 and a sum of positive 4. Will that factor for me? or they're two numbers multiplied together that give me -6, that when they add together give me +4. What were you going to say? I'm sorry.
I was going to say -2 and 3, but no, it's -2 and 4, right?
That's okay. It actually won't factor. It won't factor. So I'm going to identify my A value, my B value, and my C value. Okay? My A value is the 2. My B value is +4, and C is -3. Okay? So I've got, and I'll write, the quadratic formula is -b plus or minus the square root of b squared minus 4ac.
Under D?
Yes.
As E?
This is E. That's just the quadratic formula right there.
Okay.
And I will give you that. I will give you that. Okay? So now I'm going to do -b plus or minus the square root. Okay, I should have written 4 for -b, and I wrote -b. Sorry. So I have -4 plus or minus 4 squared minus 4 times A times C. Okay, and all of that is over 2 times A. Okay? So now we're going to simplify this. Okay? So I have -4 plus or minus the square root. 4 squared is 16. -4 times 2 is -8. -8 times -3 is 24. Okay? So a lot of times students will get to this point right here. Oh, whoops. So it's -4 plus or minus the square root of 40 over 4, and they will stop. But we're not done, okay? There's a couple of things happening. The -4 and the 4 can cancel, and the square root of 40 can be simplified. So we've got to keep going. Okay, so here we go. I've got -4 plus or minus the square root of 40 over 4. So I want to start with my 40. What does that break down to? One of them has to be perfect. Good, 4 and 10. Okay, what's the square root of 4? 2. So I have -4 plus or minus the square 2 on the square root of 10 over 4. Now we're going to break this down into two fractions. So I have -4 over 4 plus or minus 2 on the square root of 10 over 4. -4 over 4 becomes +1. My 2 becomes 1 and my 4 becomes 2.
It's still -1.
It is still -1, thank you. Okay, thank you very much. And then what am I left with over here? Good, square root of 10 over 2. Now, can I divide square root of 10 over 2 and get 5? No, because the square root of 10 is inside and the square root and the 2 is outside. Okay, so now let's draw.
So I'm assuming it's fine if I have it as 1/2 times the root 10.
Oh, yes, absolutely fine. 1/2 times root 10 is fine. So here, we're gonna,
So that's the end of E.
that is the end of E. Yes, ma'am. That is the end of E. Okay. What was my vertex? Negative 1, 5? Oh, negative 1, negative 5. Okay. So I'm going to start with my vertex. And my vertex is negative 1, negative 5. So that's my vertex right here. My y-intercept is negative 3. So there's my y-intercept. Okay. Now, you're not going to know. I mean, you could figure out negative 1 plus or minus the square root of 10 over 2 on your calculator. There's no reason to. You're just going to have it come up like that. Okay? So I'm looking for where the vertex is, where your y-intercept is, and a loose approximation of where your zeros are. Okay?
So it is negative 1, negative 5, negative 3.
Yes. And then it's opening up. And then it's opening up because of the positive. Alex, you said you had negative 1 plus or minus 1/2 on the square root of 10? Like that? That's fine. Just don't put your square root of 10 in the denominator. Right beside it is fine. Okay? We good? Can I go to the next screen? Okay. So this is number 2 on your test. Okay, and we are going to give exact answers. That means no decimal approximations.
Yeah, because when I went to tutoring yesterday, my tutor didn't understand the question. And like give exact answers, he was like, what does she mean by that? I was like, I don't know.
It means no decimal approximations. Like when you do the quadratic formula, you leave it as square root of 2 instead of finding the decimal approximation. Okay. So number 2 is 2x to the third minus 3x squared minus 8x plus 12. Okay? It looks like we might be able to factor this. Okay, is there something that comes out of the first 2 terms? Good. So x squared, then I'm left with 2x minus 3. Okay, when that third term is negative, what is that q that we got to pull out? A negative. So that's minus 4. So this factors very nicely. I'm left with x squared minus 4 times 2x minus 3. Am I done factoring? No, I'm not. That x squared minus 4 is difference to perfect squares. So that's x plus 2, x minus 2, and 2x minus 3. Okay? At this point, what do I do with each factor? Good. So x plus 2 equals 0, x minus 2 equals 0, and 2x minus 3 equals 0. So negative 2, positive 2, and 3 over 2. That's my final answer right here. Give exact answers.
That means what again? No decimal.
Approximations. No decimal approximations. So I would, so if you did a decimal for 3 over 2, you would get 1.5. And that's an exact, but basically it means leave everything in square roots and leave everything as fractions. Is what it means. Okay?
And if you were to put a decimal on the test, would that be wrong? It's not where you're asking for.
It depends if it's a decimal for the square root or, so do you see the 3 over 2? if you put x equals 1.5 on that, I'm not going to count it wrong. Okay, that would be totally fine right there. If you did -1 plus or minus 1/2 square root of 10, and you gave me 0.5638 from that, I would take points off for that because I want the exact answer. If you turned -1 plus or minus 1/2 over square root of 10 into a decimal, you would have to round. It's not an exact answer. It's an estimate, and I want it to stay exact. So keep things as fractions and keep things in square roots. Okay? Good question. Okay, number 3. Number 3 is x to the third minus x squared minus 8x plus 12 equals 0. Now, at first glance, we might be like, okay, I should be able to factor that because it's a polynomial with 4 terms. A lot of times, a polynomial with 4 terms, we can solve by grouping. But when I solve this by grouping, does it work? Mm-mm. So we're going to have to use synthetic division. So when you try synthetic division, you're going to look only at factors of 12. Okay? You don't need to worry about anything that's not a factor of 12. So tell me my factors of 12. Plus and minus.
1 and 12.
Okay? And plus and minus.
2 and 6.
Okay?
3 and 4.
Okay? So, I know that seems like a lot, but it's really not that many when you think about infinite number of possibilities. Okay? So I'm going to start with positive 1, and if that doesn't work, we'll move on. Okay, so I've got positive 1. I'm going to write down my coefficients. So I have 1, -1, -8, and 12. Okay? I'm going to bring the 1 down. 1 times 1 is 1. 1 times 0 is 0. 1 times -8. Did that one work? No, doesn't work because what do I need? I need a remainder of what? 0. What do you guys want to do next? Do you want to do 2 or you want to do -1?
I'll do -1, you do 2.
Oh, so you want me to do 2, you're going to do -1? Okay. Awesome. Okay, so I'm going to go down. So I'm bringing 1 down. 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. -8 plus 2 is -6. 2 times -6 is -12. Did it work? Yeah. Okay. So now I have 1x squared plus x minus 6. Can that be factored? And if it can't be factored, what do we have to use? Anybody have any luck factoring it? It is. It is. Which one's positive and which one's negative?
Positive 3, negative 2.
It is positive 3. Why?
Because the positive 3 plus negative 2 is 1.
Good. Your sum is 1. Excellent. Your sum is 1. Your product's -6. Now, what would be really easy for me to forget?
X minus 2.
That second 2. You see that second 2 up there? Okay. That's another factor here. Now, in this situation, we end up with x equals -3, and then we end up with x equals 2 twice. So I likely would not have missed this problem, but in any other type of problem, I would have. Okay? Now, what's the multiplicity of -3 in this situation? 1. Okay, it shows up once. What's the multiplicity of 2? 2. Why? Because it shows up twice. Okay?
I don't feel confident on those. Are we gonna have to say the multiplicity?
You might. Yeah, you might. So if it shows up more than once, it has a multiplicity of however many times it shows up. Okay? So do you see how this one showed up twice?
2, yeah.
The number 2
Yes.
showed up 2 times.
Okay.
That's kind of confusing. So the solution of 2 has a multiplicity of 2 because it showed up there twice. Okay? That's what multiplicity means. Multiplicity means is how many times does the answer show up. Okay? Now, let's move into some complex answers. Okay? Here I've got number 4. Number 4. X to the 4th minus x to the 3rd plus x squared minus 3x minus 6 equals 0. Okay? That has 5 terms. It has 5 terms. So what do we have to do?
Take out something.
Okay. We can't factor by grouping. We can only factor by grouping when there's 4 terms. We have to use synthetic division. Okay? And we're looking at factors of what to get started? -6. Okay? Or just a 6. Yeah, because you're going to do the both positive and negative. So I'm going to have positive and negative. What are my factors? 1, 2, 3, and 6. Much nicer than 12 or 24, right? Okay, let's start with 1. Okay, so now I'm going to write down the coefficients. Okay, so I'm using synthetic division. I bring the 1 down. 1 times 1 is 1. -1 plus 1 is 0. 1 times 0 is 0. 1 plus 0 is 1. 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. Does that work? No. Okay, what should we try next? Could we try -1? I mean, because we could try 2, but we need
Tried -1. I didn't get it.
-1.
Yeah. Is it -1? Because I tried it and didn't get it.
-1 should work. But we can also start with 2.
Well, then do -1 on the square.
Okay, so nope, Shay wants to do 2. We're going to do 2. We're going to bring 1 down. Okay, 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. -3 and 6 is +3. 2 and 3 is +6. Did it work?
Yep.
Did you get your -1 to work? Good. Okay. Okay. So don't forget, this is a solution. Don't forget that. Sometimes we forget it. Okay? So now I've got x cubed plus x squared plus 3 plus 3. And we're going to set that equal to 0. Can that be factored? I forgot an x, didn't I? Okay, now if you did -1, you're going to have a little bit different polynomial here, but you'll still get the same answer. It actually can be factored. I think it can be. What comes out of the first 2? Good, x squared. And I'm left with x plus 1. What comes out of the next 2? Good. Okay, so I have x squared plus 3 and x squared, or just x plus 1, I'm sorry. Now, don't forget about this 2. It's still hanging out there. We already know that it's a solution. So sometimes I'll write over here solutions as I figure them out. So I know that 2 is a solution. Okay? Now I'm going to put x squared plus 3 equal to 0 and x plus 1 equal to 0. Now you probably already know that x squared plus 3 is going to give us a little bit of something different. But you should know that x plus 1 just equals x equals negative 1. So I can go ahead and write that down as a solution. Okay? X squared plus 3 equals 0 is not too bad. I end up with x squared equals negative 3. When I take the square root of both sides, what do I have to put on the right-hand side? Good. X equals plus or minus the square root of negative 3. Okay, what's the square root of negative 1?
0?
I. Square root of negative 1 is I.
Yeah.
Okay? So,
That's my next guess.
you're good. You're good. So this is going to be x equals plus or minus I on the square root of 3. Okay? So I have I on the square root of 3, and I have negative I on the square root of 3. Now, if you wrote plus or minus I on the square root of 3 on a test, you'd be fine. I'm not going to count that wrong. Okay?
So, just going with negative 1, we would still end up with the same.
You would have ended up with exactly the same. Probably x squared plus 3 and then x minus 2. Like, you see where I got x squared plus 3, x plus 1? You likely would have gotten x squared plus 3, x minus 2. So we would have gotten exactly the same factors, just in a different order. Okay? Can I go to number 5? Okay. So your directions say simplify by rationalizing the denominator. Okay? So I'm going to tell you on your test that you need to rationalize the denominator. So what I have for number 5 is 2 plus I over 4 minus 5i. So I'm going to rationalize the denominator, so that means I need the conjugate of 4 minus 5i. What's the conjugate of 4 minus 5i? Good, excellent. And not inverse, not inverse, no. Okay, so 4 plus 5i. If I do that on the bottom, what do I do on the top? Good. Sometimes students want to multiply the top by the inverse of the top, but that's not what we want to do. Okay? Okay, now I just FOIL both of them. 2 times 4 is 8. 2 times 5i is 10i. I times 4 is 4i. I times 5i is 5i squared. We'll deal with that 5i squared in a minute. Then we're going to do the denominator. 4 times 4 is 16. 4 times 5i is 20i. Negative 5i times 4 is minus 20i. Negative 5i times positive 5i is negative 25i squared. Okay? So in the numerator, I'm left with 8 plus 14i plus 5 times negative 1, because I squared is negative 1. What happens to my 20i and my negative 20i? Good. So I'm left with 16 minus 25 times what? Negative 1 times negative 1. Okay? So 8 plus 14i minus 5, 16 plus 25. So my final answer here is 3 plus 14i over 41.
So when you're doing the numerator, we have I, real number first.
Mm-hmm. Yeah, that's standard form of complex. Okay. Okay. This is something that we did not do in class today, so I'm glad we're going to get to do it right now. we did not get to rationalize, or not rationalize, I'm sorry, we did not get to talk about a rational function. Okay, so let me look at number 6. Can I go off this screen? Okay, so number 6 is not too bad as long as you understand all the vocabulary. Okay, so I am given the function x squared minus 7x plus 12 over x squared minus 3x minus 18, and we'll put this equal to f of x. Okay, so the first thing that I am trying to find is the domain, and the domain is determined by my denominator. That's the important thing to remember about domain. Domain is determined by the denominator. Okay, so I'm going to go ahead and factor this just because it makes it a little bit easier to manage. My numerator factors to x minus 3 and x minus 4. And my denominator factors to x minus 6 and x plus 3. Okay? So to find my domain, I set my denominator equal to 0. I find what my x cannot be. So I'm going to have x minus 6 cannot be 0, and x plus 3 cannot be 0. So x cannot be positive 6, and x cannot be negative 3. Okay, that's my domain. Now my domain has to be written in interval notation. Where do I start when I'm writing something in interval notation? Good, negative infinity. Now, which one of these two numbers is smaller, 6 or negative 3? Good. So I'm going from negative infinity to negative 3. Okay, and then I put a union. What do I have to put in the middle that looks like an ordered pair and sometimes students forget?
Negative 3 to 6.
Good. Negative 3 to 6. And then,
Do you always put the vertical asymptote in the middle?
yes,
That's-
your vertical asymptotes are going to be where it's undefined. So x equals 6 and x equals negative 3, that's where my vertical asymptotes are going to be. Good. Okay, so what's my last? Yes. And Shay, you should always be seeing those numbers in your domain, and they're going to show up again in your vertical asymptotes. Good job. And that's our next question. Identify our vertical. Oh, you're good. No, you're good. Identify your vertical asymptotes. Now, on the answer key that I'm going to put online, I wrote down, these are lines. Okay? So you need to write x equals negative 3 and x equals 6. These are lines. Don't just write negative 3 and 6. Write them as lines. Okay? Now I need my horizontal asymptote. My horizontal asymptote focuses on the relationship between these two right here. Okay? It focuses on the relationship between those two. What degree is my numerator? What's my highest exponent? What's the degree of my denominator? So when those are the same, what is my horizontal asymptote? It's 1 because of this situation. Okay, the ratio of the coefficients is 1 over 1. So it is y equals 1. Correct. Correct. Okay. Now, my x-intercepts focuses on what? Yes, good job. Okay, so I'm going to have my numerator equal to 0. So I have x minus 3 equals 0 and x minus 4 equals 0. So this is going to be where my graph crosses the x-axis. Now, I'm not graphing it. I'm just asked where my x-intercepts are. Now, you could write that as x equals 3 and x equals 4. Or you could write it as 3, 0, and 4, 0. I'm actually okay with any of those. Okay, and the last thing that I'm asked for is my y-intercept. My y-intercept. Now, you can cover up everything that has an x in it. And when I do that, I'm left with 12 over negative 18. Okay, but you can also do it where I do 0 squared minus 7 times 0 plus 12. Okay, and I'm left with 12 over negative 18 as my y-intercept. What does that simplify to? Negative 2 over 3. Good, you got it. 6 goes into both of those. 6 goes into both of those. Okay, so that is one we did not do today in class that, you know, you want to kind of make sure you've got. Okay.
Tutor was confused about one too, like asking how to find it,
How to find
the,
the asymptotes?
yeah, my confidence is kind of
Yeah, we
going
can-
low on him.
Yeah, we can talk about that in just a second.
Yeah.
Okay, so number 7 is we're going to use synthetic division. Now, I want you to look closely at this. I've got x to the third plus 6x plus 5 divided by x plus 2. Okay, now yours probably looks totally different. I did change it.
Yeah,
Okay,
it's like 80.
yeah, I know, it's totally different, so I changed it. And if you print the new one out, it'll be this. Okay, now what am I dividing by? X plus 2, but what do I put in the box? Not 2, not 1. Negative 2. Let me tell you why, Shay, okay? X plus 2 is the factor. What is the solution associated with that factor? Good. That's why we put the negative 2 there. Okay, now, where could I make a mistake?
Leaving out the 0 for x squared.
Yes, you see this, guys? We've got x to the third, and then we go to 6x. Don't leave out the 0 associated with that x squared, okay? You can expect at least one like that on the test, okay? Where you're going to have to find, you've got to plug in a 0 for something that's missing. Okay, so now I'm going to go down. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4. Negative 2 times 10 is negative 20, and I have a remainder of negative 15. And that's okay, because I'm just dividing. I'm not trying to find solutions. I'm not trying to find where it crosses the x-axis. I'm just dividing. But we don't stop here, okay? Negative 15 is my remainder, so that's going to be negative 15 over something. 10 is my constant. Negative 2 is my x, and 1 is my x squared. So I have x squared minus 2x plus 10. What do I write that negative 15 over? Excellent. Okay. Okay. I think our next one is graphing.
So instead of plus negative 15 over x plus 2, you can do minus 15 over x.
Yes, you could. That would be exactly the same. Good job. Okay. Okay.
For a minute, I'm gonna go back.
Yeah, I'll come back to it. I just have to be careful because of time. I think there's a class in here at 2. Yeah, you go ahead and then I'll come back to it. Uh-huh.
Class.
Okay, you go. You go. Okay. Are you staying? You good? Okay. Okay, so now we are going to graph x to the third minus 7x plus 6. We're going to graph that. Okay? The first thing that I want to know is I want a description of what the function looks like. Are they going to be going same direction or opposite direction?
Opposite direction.
Good. So
Positive slope.
good. And so it's going to look something like this. And that's enough. You know, I can just have that general direction. Okay? Now, part B says the intercept of the function. So to find the intercept of the function, I plug 0 in for x. So I would have 0 to the third minus 7 times 0 plus 6. So my y-intercept is 0, 6. Good job. Okay. Now, part C says identify the solutions to the function. Identify the solutions to the functions. Now, you do set the equation equal to 0. So I'm going to have x to the third minus 7x plus 6 equals 0. Okay. When I set this up using synthetic division, I have to be sure I include my 0 right there. Okay, because I don't have an x squared. Now, what numbers am I looking for? What numbers can I stick in there?
1, 2, 3, and 6.
1 plus or minus 1.
Minus.
Yeah, you're good. Plus or minus 2, plus or minus 3, and plus or minus 6. Now, just for the sake of time, I'm going to go ahead and pick, pull a 2 out. Actually, 1 would work too. We'll do 1. Because that's probably where we would start, is positive 1. So I'm going to pull my 1 down. 1 times 1 is 1. 0 plus 1. 1 times 1 is 1. Negative 7 plus 1 is negative 6. Okay? So don't forget that 1 is a solution. Don't forget. Then I've got 1x squared plus 1x minus 6. Okay? That can be factored to x plus 3 and x minus 2. Okay? So I have x equals negative 3, x equals 2. But don't forget, I've got one more. What's my other one?
1.
Good. It's x minus 1, so my solution is x equals 1. Okay? So part C says identify the solutions to the function. Okay? So my solutions are 1, negative 3, and 2. Part D says write the function in completely factored form. Write the function in completely factored form. Okay? So completely factored form is this right here. Okay? So these are my linear factors. X minus 1, x plus 3, and x minus 2.
And wouldn't it not matter what order?
Doesn't matter what order. Doesn't matter what order. Okay? Now I'm going to graph it. Okay, now, I know that my y-intercept is positive 6. Okay, so there's my y-intercept. I have solutions at negative 3, at positive 1, and at 2. Okay, and we also know that my end behavior looks like that right there. Okay? That's what my end behavior looks like. So, based on that, we can draw a smooth curve. So I am looking for your x-intercept, your y-intercept, and direction. X-intercepts, y-intercepts, intercept, and the direction of your graph. That's what I'm looking for. Okay? Okay. I have to stop this now.